Okay, so I think that there are some students in the class who have not done networking course. I think some MTech students who have come from EC background. So I thought it's a good idea to revise the basic concept of networking. Okay, such that you have, a top level view of how networking works, right? And BTech students have all done a networking course, so I think you have fairly good idea about what networking is. Okay, note that networking is a different kind of subject wherein you have to visualize a lot. Okay, and you have to draw analogy. Without drawing analogy, understanding of networking is difficult. So I would, whenever you read something, you have draw analogy with the real world, and you'll get an example. For example, whole internet, you can visualize this as a postal system in some sense, right? And of course, you can then there might be minor differences, but top level concepts can be the same. Okay, so draw analogy, only then you can understand, right? Like we have multiple layers in networking, right? And understanding what each layer does is extremely hard. If you just look at, a packet moves from higher layer to lower layer and something gets added, and on the other hand, when it's processed, those things what are added gets deleted. It looks quite complex. Okay, so best is to visualize, and then when you're visualizing and you're trying to understand the concept of protocol, okay, then you can see where the problems are and what are the security holes, and how we can plug it up. Okay, all right. Okay, so today's lecture I have taken only from one source. I think it's lecture number yeah, it's 25 only. Okay, same place, right? And so today we'll not be going into details, but look at we will visualize how things really happen. Okay, in network. Okay, all right. So these are the topics we'll cover, and I'm sure you know most of these, right? Okay, all right. We have discussed this point earlier. Suppose you are in island, just very small island, and you are the only person with your laptop, and there's no connection, no internet connection, no connection with the outside world, no satellite connection. Then you don't need any security, right? So you are here. Somehow you reach there, and you just want to spend few days in isolation. You don't have any connection, even no mobile phone, then you don't need, okay, any security at all. Whatever you do in a laptop, as long as the battery is there, you do it and then close it. Nobody can steal your data. Okay, however, we have seen that as number of connection grows, the utility of that node or your machine improves, right? And there is a law around that. Possibly you would have studied in economics or something. More connections you have, more useful equipment or more useful you are, or whatever node is. Okay, if you have very large number of connections, then you can do a lot of more things. Okay, if you're connected to only one server, for example your laptop, then only limited things you can do. So internet is a great place, and the technology came after many centuries wherein you can connect to anything that is on internet. Okay, now the richness of all that is because of large number of connections. If you have only access within your campus, then only limited things you can do. You can't have Google, Microsoft, or whatever application, thousands of applications. Okay, the more number of connection any system has, is its value grows up. I think is not linearly, but is kind of square of that or exponential, I don't remember. So there is sort of non-linear way, the importance of that, utility of that increases. Now at the same time, more connections you have, security reduces, because now anybody from anywhere can reach you. For example, in internet, anybody from anywhere can reach you. The person who is hacking your device and storing your credit card data and doing other things or doing bank transactions on your behalf may not be in the same campus. It could be in anywhere in the world. Okay, so your attack surfaces increases if you have more connection. Like on the internet, everyone on internet has same connectivity, whether you are the president of US or you are a student or me. Internet same. I can reach to so many places as anybody else. All right, so now with since my attack surface increase significantly all over the world, anybody can attack me. I have to think how to protect myself. And this problem was not there just 30 years back when internet was just beginning, right? Okay, I mean, when I started internet, fortunately, I was part of the team that did first time sent emails in India. That was in IT Delhi. We had ERNet project. So kind of first few days, all ITs, some of the ITs started sending, had this program and they started experimenting with emails. Okay, at that time, use of internet, or actually that time internet was not there really, but use of communication was only to send emails. Okay, when internet came, also utility was very, very limited. But now internet, because only few points are connected to them, now everything is connected. Billions of devices are connected. Okay, it's machine to machine communication. Now the attack surface is increased. Say device sitting in Nigeria can hack your machine. Nobody can stop that, right? As long as your machine is exposed and on internet, anybody can use that. All right. So remember that more the connections, less secure you are, and you don't have any control over connections, right? I mean, the internet has same number of connections for everyone. All right. So our attack surface is huge because today networking is nothing but internet. Okay, and then we'll have to think how to secure ourselves, and millions of things can go wrong in a network. Okay. What can go wrong? For example, let's assume everything is secure, and you are in Bangalore or Goa or Delhi, and you see that cables hanging. Interestingly, in India, the fiber cables that go from one place to another, there's no structure. There is no underground cabling system, right? Generally, you can see that cables are hanging out. I mean, goes from one tree to another tree, and all kinds of things you see. Okay, as simple as that, somebody can cut the cable, and it happened in the company where I was working. The whole area's fiber cable was cut by thieves for some reason or other. Okay, so this is the simplest kind of security insecurity or security problem the outside world can cause. And just about 20 years, 30 years back, when fiber cables were not in use, then copper cables were there, and then two set of entities had interest in it. First, thieves, because copper is expensive. Now thieves don't want to steal fiber cable because fiber is extremely cheap and they have no use, they can't sell it. Okay, and second is rats. Rats enjoy cutting cables and cables, but rats don't have much interest now in fiber cable. Okay, so there is the simplest kind of security that somebody with a big scissor can come and cut all the cables of area, and everything will go blank. Then all network will go blank. That's the lowest level of security. It's kind of physical security. And to the highest level of thing where you can think of, whole country's traffic is diverted to a place in China, and then they observe, store everything that's happening between, say, traffic going out of India. And that kind of hacking happened not for India, but in traffic for few minutes or something was diverted to China some 20 years, 15 years back. Okay. And for that, they simply did the hacking of one routing protocol. So you would have studied BGP, right? Did you?
Yes, sir.
So BGP, they did manipulation, and then that made whole traffic to pass through China. Now, one beauty you can see in networking, and that beauty is there's a base on trust. Okay, when you send your packet, or when you send an email, do you really want to check where all your email has traversed through, what routers has gone through? You don't know, you don't care. Okay, as long as it reaches. But the question is that it might have gone through routers of many organizations which you don't know. Okay, it's not that only ISP, up to ISP is all connection of ISPs. Okay, so the whole, there is a concept of trust, and when networking evolved, internet evolved, nobody thought of security. Everyone thought of, because it was kind of experimental network and nobody believed that there can be major security flaws. So the whole design of internet is based on trust. Okay, now the world is not that simple, of course. So there can be a lot of things can go wrong, right? And this is exactly what's happening. See, internet is nothing. Internet has not been designed for security. Data networking has not been designed for security. It's designed for a lot of other things. So there's hundreds of things that can go wrong because the whole system is not designed considering security in mind. But it's a design thinking of reliability, it's thinking of flexibility, it's thinking of efficiencies. These three things have been considered while designing the networking, but not security. As a result, security is open pipe. Now you'll have to do something to make it secure. And that's what those tools and mechanisms will study in next 10 or 15 lectures, right? So these are some of the things which I could think of, and this is just partial list, okay, which can go wrong. Okay, so we'll look at some of these. We'll not go into everything, but we'll look at some of these. Okay. So now we'll look at concept of networking, and you have to visualize how things really happen. Okay, and then you'll get the fairly good idea. Protocols we know. So beauty of networking is that two entities. First thing is that it's is not centralized. It's not centrally controlled system. It's purely distributed system. The internet of today is purely distributed. Of course, there is new technology called SDN. Some of you would have heard of this technology, software defined networking. That's not truly, and sorry, SDN is also used in data centers. Okay, because they want a lot of control. So it's not truly distributed system. Okay, so possibly if you're interested, then possibly go through literature. Okay, or maybe you can request your networking teacher, so he or she can teach you that. But in general, the internet today is purely distributed network. When you say distributed, what do you mean by it? Can anybody tell me distributed network versus centralized network? What's the difference? Like Gunjan, can you tell me? Are you there, Gunjan?
Yes, sir.
When we say distributed protocol, what do we mean by it? A distributed system versus centralized system, same concept we can apply. Think na, just
So, distributed network, all the information is distributed between the nodes of the network.
Yeah, all the information तो हो सकता है ना, लेकिन when we say distributed system in general, of course there is a
So it's not owned by a single entity.
Yeah, partly correct. It's not controlled by one, and it's a peer-to-peer networking in general, right? So both entities run the same protocol. In networking context, distributed system run distributed systems. Let's not about computation. We think only of communication right now. In communication, when we say distributed system, purely distributed system, it means that both entities run the same protocol and have similar state machine, exactly similar defined state machine. Okay, because all they have is syntax and semantics. Syntax define the format, and that format must be understood by other entity, and semantics is essentially what it does. Okay, so for example, whether checksum sequence is used or not. Okay, and how checksum sequence is used by recipient. So all syntax and semantics put together defines a protocol, is a rule essentially, right? Okay, so here the state machine that we have and the state machine here has same number of states. Okay, so it may be router may be developed by Cisco, or this may be developed by Juniper, or you yourself can develop a router, but this exactly same protocol they run. Otherwise, the communication world cannot operate. Okay, so Ethernet packet, for example, Ethernet frame has the same format, whether it's developed by Cisco or Juniper or Brocade or whoever, or Amazon. Okay, so protocol is essentially an agreement in how to communicate. It includes both syntax and semantics. Okay, and the protocol is set of rules. So for example, in a normal classroom teaching, every teacher has a set of protocols. Okay, when teacher is teaching, the students should not talk to each other. There's possibly a protocol. If somebody wants to ask a question, then they raise hand. All right, like here in online classes, set of rules are different because I can't see you have raised hand. Okay, so best for me is that you interrupt and ask questions, but you can't interrupt me when I'm talking. You can interrupt when you see there is a gap between when I'm speaking, this gap in between my sentences, right? Okay, or when I ask that please ask questions, you can ask questions, right? So set of rules are different. Okay, so these set of rules are nothing but protocols. Similarly, networking has a protocol, set of protocols, and networking world is full of protocol. There may be more than 500 protocols, and that confuses everyone. Okay, and so many acronyms. Okay, so that's the reason visualization is important. Once we understand how things really work, once we visualize, then protocols are nothing but a set of rules defined to do that activity. Okay, so let's do one thing. Okay, the laptop is off. Okay, and then you think that, okay, let me go to a coffee shop, okay, and do some work. And many coffee shops have internet connectivity, so you go to one of those shops one of those cafes where you go regularly. Okay, so you walk into a coffee shop, open your laptop and search Google. Now, can someone tell me what are the steps? Now, your laptop is of course booted. You have just when you came in, it's already in a sleep mode. Okay, and you wake it up by opening the laptop cover. Okay, it has opened up. Now, what is the next step? You have studied both OS and networking, so you should be able to answer. Who can tell me? Harshit Jain, can you tell me? I hope your microphone is working today. Harshit, are you there?
Yes,
Okay.
sir.
हाँ बोलिए बताइए. You go to a lab or coffee shop, open your laptop, and you want to connect with Wi-Fi. What does it happen after that? What happens after
Uh,
that?
okay, sir. So it tries to connect to the Google server through TCP protocol.
अरे यार गूगल तो बाद में पहुंच गया. बाद में जी गूगल सर्वर तो बहुत लेट आया है. First, what is the
Yeah.
first thing that your laptop will do? Do you have IP
Yeah,
connection? Do you have IP address?
yeah. It will connect to the DHCP server for the IP address.
Very good, excellent. So how do you connect it? You don't have connection.
Yeah. So, sir, I will enter the password for the Wi-Fi, then which in return authenticate me as a user, and then connect me to the DHCP server, which in turn give me the IP address and DNS server addresses.
Wow, very good. Okay. And then what is the next thing?
Then it will I will then have uh, I I will store the keys and establish the connection, and then I can request I can
Store the keys.
use
Which
internet.
keys? Which key you're talking of?
Yes, actually password keys.
Oh, basically you say that Wi-Fi of course requires security.
Yeah,
Okay, so you have encryption. So good,
yeah,
good. So you have keys. You will use it for communication over Wi-Fi, because these keys are used only between two ends of Wi-Fi, right? From your laptop to the Wi-Fi server.
yes, sir.
All right, that's good. What is the next? You have DNS. You got IP number address. Then what is the next step?
Uh, then now I can use internet if I am connected to the ISP.
Yeah.
So
So you are on internet. There's no other network nowadays, right?
yeah,
So what protocol you use to connect to Google?
to Google, sir, it will be HTTPS and TCP IP.
Okay, very good. So how do you know Google's? See, your browser needs only IP address.
Yes, sir.
How do you know Google server there? Google server might have hundreds of IPs, hundreds of servers,
Yes, sir.
and these servers may have different IP addresses, right?
Yes, sir.
How do my laptop or your laptop knows the IP address of?
Yes, sir. So for that, we use DNS servers. That's why we got the DNS server IP address.
Okay,
So yeah, we send the request to the DNS server with the website name. Then it resolves it with the IP address. So
okay,
we either buffer it, cache it in our network, somewhere in the network or in our laptop, so that we don't have to do it frequently. Like first time we need to go to the DNS server, then we don't need it much second time.
okay. Very good. I'm very happy that I'm very happy about your knowledge of networking. Excellent. Very good. This is exactly we were trying to tell you. Possibly you would have seen these slides. Okay, it's very commonly used. So here is Alice in coffee shop. Okay, she has just opened her laptop and she wants to connect to Google. the next step is join the wireless network. Wi-Fi. She may not have Ethernet cable. Nobody gives Ethernet cable in labs, in cafes, right? And your laptop then will shout, does wireless network X exist? Because she may have, she might have stayed here and then ask, does this network exist or not? Okay. So your laptop may have list of Wi-Fi networks addresses, okay, or names. Okay, and at the same time, cafes Wi-Fi router says that I am this network, say network Y, and do you want to connect? Okay, so all right, just a minute. Okay, so either of these match up, then your laptop joins the network. Okay, it has joined the network. So there is some, basically some protocol, okay, to do that. What protocol do we use in Wi-Fi? Anybody can tell me? You use it, right? And when you configure your laptop, configure your Wi-Fi connection, then you see that, right? It asks for, it tells you. Anyone? Anybody can answer me that? Okay. WPA, yeah. Okay. Earlier it used to be WEP. Is WPA nowadays used, right? Now if now this is all open, right? It's like you are in a room, classroom, and then you are talking to your friend on mobile, and then everyone can listen. So if it's done in open, your neighbors and everyone can intercept and read. They can find out what communication is happening. So it means that we have to have on Wi-Fi we have to have encryption. How can we secure when everything is in open? We can secure only by cryptography. Okay, so this connection, which is a link, has to be have encryption. And what kind of encryption it will be? Symmetric or asymmetric? Because there is a stream of data that's being transmitted. It is symmetric. For encryption of data, what kind of protocol we are going to use? We have studied that. Yeah, try na. Anybody can tell me. You can tell me. Gunjan, can you tell me?
Sir, is it AES?
Yeah, I mean basically symmetric key encryption. Okay, because I mean we have studied that asymmetric key encryption is very slow. It can be used for key exchange, or it can be used for initial handshake, or if your message size is very small, then you can use it, right? But most of the time in bulk communication, like it happens on network, you cannot afford AES. The key size is also very long in case of asymmetric, right? So we have to have very efficient method. Efficient method is only symmetric key encryption. So this is symmetric key, but the question is that how do we both ends know the key of each other, because it's the same key we are going to use, and for that we have to use AES, key exchange, sorry, key exchange protocol, asymmetric key. Okay, so this, now we can apply what we have learned, that now we have asymmetric key protocol in the beginning. It could be Diffie-Hellman or whatever for key X, such that we establish a common key. or session key that will be used by both entities, these two entities, right? And then this key exchange, then encryption happens. And how long this symmetric key should be valid? This key, the same key that both entities have, how long it should be valid? Now note that everything is in open here. So now, most modern protocols say that this time should be very small, maybe few packets. Every few packets transmission happens, then they change the symmetric key. Okay, all right, good. So here we are. So the both entities have exchanged symmetric key and established secure connection. What's the next thing? You have to configure the connection. Now she doesn't have IP address. Okay, and other information. Like she also needs, this all is in a network, and then she needs address of the gateway to get out of this place, right? So address of the gateway, which connects to the external world, because she is in the LAN. Okay, all right. So this basic configuration parameter, which is more than one. Okay, she needs. So her laptop says that, can somebody tell me configuration parameters? Because like my IP address, gateway address, and few other things. Okay, DNS server address and so on. Okay, and then the next thing is that within the net, there will be somebody. That's how local area networks are configured. That somebody who can send her all this information. So we use DHCP protocol for this, right? So DHCP protocol, which sits either in this server or any machine in the net, will answer back. Okay, all right. So now this guy has responsibility or works as configuration server. Will send a DHCP server will send the configuration details to her. Okay. Now she will get the following. First, most important thing is IP address. Okay. Now she will get 32-bit or 64-bit, whatever configuration server or DHCP server wants to give. Okay, and what is the second thing? It will be gateway, address of the gateway, so that she can go beyond local network. And third is the DNS server address. Right? Now domain name server we need because she wants to do google.com, and this has to be converted into IP address. Only then she can use TCP. All right. So she gets now these three as okay. Now she wants to know what is, so she gets all these three things here. Now she wants to send DNS request. She wants to know where is google.com. So she sent this request or UDP. Okay. And then DNS resolver might not be in the same local network. It can be anywhere. Okay, then her request will go hop by hop to until this query is resolved. So there is a sequence, or there is there are multiple DNS server. It's a hierarchy, and if the local DNS server is not able to resolve, it goes to next level DNS server. Right? So all right, so DNS server is, for example, here resolver is here. It will give the mapping of google.com to corresponding IP address of the server, and will send back, and her laptop will get that. Okay. All right. So she will get this IP address of google.com. Okay. All right. So here, this point says that if the first DNS server is not able to resolve this, doesn't know where google.com is, then that machine will send it to higher level domain name servers, and finally it will get resolved. Okay. So finally, as we mentioned, that this guy knows where is google.com, and the IP address is this one, and then this gets communicated to Alice. All right. Now Alice uses some protocol to connect to google.com. It could be what? UDP, TCP. Is likely to be TCP. Okay. So she uses TCP to connect and then sends SYN message, SYN packet, and you would have studied, I mean, how TCP works. So sequence of SYNs are exchanged, and then her message sends SYN, TCP SYN, and then google.com, wherever that server is, it travels and finally goes to server, and then the server responds. All right. Okay. So here we are using TCP for reliability. Okay, note that word reliability. The reliability is different from security. A machine can be extremely reliable, which will never go down, protocols are robust and so on, but it may have security flaws. Okay, so two things are different. So TCP provides reliability, it does not provide security. And reliability it provides by retransmission of packets. All right. Okay, so what's the next step? So the server accepts, if TCP server accepts the connection, it will reply back with SYNAC. Okay, and then so that will complete the connection, TCP connection. All right. Now, what's the next step? Now she knows, the laptop knows that this is an unreliable connection. So something needs to be done to make it reliable, right? Okay. But she may not want just reliability, she also wants security. So she has to do something more than that. And what she does is that there is a protocol called TLS or HTTPS that we often use, right? And she uses that to create a secure connection. Now again, note that how do we achieve security here? Note security in open world and internet, we assume that anybody can see, can be achieved only by encryption. Okay, in order to first exchange keys, she needs to know public key of this. Okay, when she knows public key, only then key exchange can happen. And what this guy will do, this can be any, not necessarily, see, DNS server can also be a ROG DNS server, right? Or it's basically malware can be there, it can give wrong IP address of google.com, and google.com can be in some place which is not actual google.com, but that IP address may belong to cyber criminals. So this guy has to send a certificate. And we have said distal circuits, right? So google.com, this server will send distal circuit. Yes, I am what I am, and this is my public key. Okay, all right. So let's move next. Okay. So, all right. So of course, Alice wants confidential connection with integrity and authentication. And then next step is this guy sends certificate, and certificate is about the public key. Okay. And then she can, as a result of that, when she receives public key, she will send a challenge. Okay, just prove me. I will send you a random message or blob encrypted with your public key, and then with your private key you decrypt it and send the answer back to me, and I believe you are the right person. Okay, and that's the next step. All right, so this guy decrypted the message sent by Alice and send it back. So here is your proof. All right, now connection reliable, secure connection established, and she can send the query. So these are the steps. Any question? Is it all secure? A lot of things can still go wrong, and we'll study that. But there is one thing is certain, that there is end-to-end security here, right? That's the reason when it's often said never use HTTP, but use always HTTPS, because your connection is end-to-end encrypted. And many websites don't support end-to-end encryption. Okay, then you have to be very careful about it. Make sure that you have some kind of security, right? I mean, through your whatever packages you have bought. Okay, because I mean, if the site does not have HTTPS, then of course your connection is not secure. It's non-encrypted. Anybody can read your packets. All right, so let's move next. Okay, you would have studied the concept of layering, right? And these are the and we use layering very often in our life. Within OS also we are using layering, right? I mean, we have runtime library, we have code, runtime library, system calls, and this becomes an interface between, this is OS part or kernel part, this is normal non-OS part. We studied this last year, right? And then we have device driver and so on. And within next level is signal generation and all that, right? So why do we use layering? You have studied this, right, in your networking course?
So we can change a layer without like having to
Excellent.
change the entire thing.
Very good. Very good. So you may want to change this something inside. New device driver comes or whatever, right? You can make changes keeping the interface the same. Then nobody really is bothered. Whole system works. That's first reason of doing this, right? Second is that once you split the problem into sub problems, then it becomes simple to enhance, that we have just discussed, or simple to manage. Okay, that's another reason. Okay, so now networking world is full of layers. Okay, so something that we see, of course, is okay, this simple example that you see is that sending an email, simple mail. Alice wants to send it to Bob, I am hungry. Okay, she will just send this, and this mail will get enveloped, in outer envelope, and then it will be sent it to Bob. Okay, and then that's not enough, because there can be many Bobs, many places, and address is not known, then address gets attached to that, and then it goes this over surface, it goes to other end, and received by, say, let's assume that front front end or front desk clerk. Okay, and then she hands it over to Bob, and Bob opens the envelope and then gets a message from Alice. And we have seen hundreds of these examples in real life. Also the same thing happens, right? When French president talks to Indian president on messages, the French president knows only French, Indian president knows only Hindi and English, and maybe Gujarati. Then there is a protocol. French president will not come to office of Indian president or Indian prime minister, and then give the letter, right? Okay, so these are the protocols. Okay, now in OSI layer, you would have said there are 7 layers, right? While in internet, we use only primarily 4 layers. Okay, the 4 layers are physical layer, link layer, which is nothing but LAN, it becomes LAN here. Then IP layer, inter-network layer, and then transport layer. And then of course you can use applications on top. While what we have omitted in OSI is 2 layers, session layer and presentation layer. These are redundant layers actually. We don't really need that. So we have this internet stack. All right. Okay. And I'm sure you would have gone through in your last semester all this in detail. So physical layers provides, it sends bits from one end to another end. Okay. So there is a piece of wire. Okay. What kind of coding you need to do? You know, there are different kinds of codings are there. You know, I mean, essentially you have to send bit sequence, right? 0, 1, 0, 1, 1, 1, whatever be the sequence. This has to go from one end to another end. Now, how you are going to represent this in terms of signals? What kind of coding you are going to do, right? A lot of codings are available, right? Efficient. Some codings are for efficiency, some are for speed, some are for some other reason, reliability maybe. Okay, so you have to convert this another voltage signals, voltage levels or signals or whatever, and you have to send it across. Okay, put these bits here and reaches the other end, at the other end it gets collected and given to higher level. Okay, so now depending on what this medium is, you have to have this coding, encoding, and you know, way you transmit it. For example, if this medium is air, then it's totally different. Then it's a copper, then it's a fiber. In fiber, we don't send voltage signals, you know, we send only light pulses. Okay, so the depending on the medium, we have to do this, you know, mapping of sequence of bits that we receive from top or from application into actual voltage signal or light pulses and so on in a particular pattern. That's all. You know, it requires, for example, RF modulation if you're sending it to a radio wave, if photon intensities, if you're sending it over light, pattern of voltage levels, you're sending it over copper, and so on, right? Okay. All right. So it's very simple. So we'll not go into details. So note that the whole idea is that send some sequence of a pattern of signals from one end to another end, and that will represent a bit pattern or bit sequence that comes from top. What is the role of link layer? Okay, I think we have just completed. We have gone very slow. Link layer, see, a network consists of number of links. Okay, every link has a specialty, and these links are of different types, right? It could be air, it could be copper. But when we say air, it's a Wi-Fi, for example. We are running Wi-Fi. It could be Ethernet. It could be, if it is fiber, it could be anything. It could be fiber Ethernet or something else. Okay, so for each link, or which could be air or whatever, or running these protocols, you know, its responsibility is to take this bit patterns that are coming here and deliver it to other end. That's all the role is. Okay. All right. So we'll start from here in the next class, and we'll study these and very brief. See, note that I am not trying to get into bits and bytes at this point in time. When we study security, we'll get into more details, but I want you to visualize and see how things are happening. Okay, once the visualization is complete in next 2 lectures, then we will start with security aspects of this. Okay, any question? No? Hello?
No, sir.
Are you, do you have clarity on this subject so I can skip it first? Is anybody really, should we discuss this or should we not discuss this?
Sir, I think just in brief would be fine so that we get a reminder.
Okay. So this level of details you don't need, so I can possibly skip it. Okay. All right, because MTech is not, who is there in the class? Anyone?
Yes, sir.
Do you need this kind of detailing, or we can still, we are not gone into bits and bytes and protocols, but trying to create top level view, top level understanding of things, right? Do you need this or not?
Yes, sir. We need this, sir.
Okay, so we'll next class we'll try to finish layer 2, layer 3, and then we'll start with the layer transport layer. We'll skip, and then we'll start with security of these layers. All right. Thank you.
Thank you, sir.